Okay, good morning class. In the yesterday's lecture we have done shear strain energy theory. Now we will be doing the numerical. What was shear strain energy? Shear strain energy was that the failure will occur in your shear strain in the stressed material when it reaches the value of the shear strain at the elastic limit in simple tension. For this, the relation is stress 1 square plus stress 3 square minus 2 into Poisson ratio, stress 1 into 3. These are the principal working stresses, is equal to stress ET square. For this, the value of the torque and momentum is given to us with the stress and the elastic tension with Poisson ratio is also given. We insert all these values into the equation of the strain energy theory. When we insert these values, we have to calculate the stress 1 and stress 3 in terms of the movement and torque. So we have put these values in the equation number 1 and we finally get with the equation this. That is stress ET square equation. We are having now total 4 constants and 1 is unknown, 3 values we are known with. Stress ET is known to us, M is known to us, 3 is known to us, mu is known to us. We have to only calculate the diameter. After solving this, we find out the value of the diameter, that is 88.5 with the help of the strain energy theory. Now next step is that we see the value of the diameter with the help of the shear strain energy theory. What happens according to this theory? The failure will occur when the shear strain energy per unit volume in the stressed material reaches the value equal to the shear strain energy per unit volume at the elastic point in simple tension. Now in all the cases we are taking up to the elastic point in the simple tension. For strain energy theory also, for shear strain energy theory also, for simply shear energy theory also. Now this is the fourth theory which we are covering. We can calculate the value of the strain energy per unit volume for the principal stresses. This one is the value for the principal stresses. Equivalent, secondly we require the strain energy per unit volume for the elastic limit for the tension value. So this is the equation. For this, the material is given up the tensile stress up to the elastic limit, that is stress 1 will be equal to stress T, stress ET. Stress 2 and stress 3 will be 0 because we have only reached up to the stress 1. The values of the working principal stress is up to the value of stress ET. So rest 2 are 0. We insert the value 0 in this equation for 2 and 3. Finally we get the result of the strain energy per unit volume for the elastic limit, this answer. Equating equation 3 and 4, we get this final relation. Stress 1 minus 2 whole square, stress 2 minus 3 whole square, 3 minus 1 whole square equal to twice of stress ET square. Twice is because this is the value of stress ET, this is the value of stress ET, twice ET square. Per unit volume is cancelled on both the sides. So we can also calculate now the value of this quotient, that diameter, from this equation. We can change the value of moment and torque and we can simply get the answers for the diameter if Poisson ratio and stress ET is given. So this is about the shear strain energy theory. Thank you.